Welcome to class number 9 of our chiller course for beginners. In this class we are going to talk about the centrifugal chiller. It is the continuation of class number 8 and we are going to explain the operating principle in more detail. We are going to make some specifications, some terms. We are going to clarify what we talked about in the previous class. On the screen we have an animation that will allow us to explain how the chiller with a centrifugal compressor can regulate the capacity, that is, adapt to partial loads. Let's remember that a large part of the chiller's useful life is working at loads less than the maximum. It is anecdotal to think that we calculate a thermal load many times to buy a chiller and very rarely that thermal load value is present. That is, it is present in a much shorter time range than what can be believed. So we are going to analyze how the process of regulating the thermal load of the chiller with a centrifugal compressor would be. We can see the operation of the compressor in animation. We are going to detail how the compressor can begin to regulate the refrigerant inlet. If we see in the part of the we can see on the right, if we get a little closer to the right, we can see how we have these kinds of vanes that are going to open and close according to the amount of refrigerant that is needed. There we see the animation of how the refrigerant is entering through the eye of the compressor, and we see how these blades can be closed to let less refrigerant pass and thus only compress the refrigerant that is needed. They will be varying according to the thermal load that it has. So in this way the compressor can only perform the work to the amount of refrigerant that is needed in the plant. Now if it is true that we close that flow has to have, that regulation has to also have an effect on the pressure in some way we can think about it, and if in fact it has.
If you want to acquire more advanced knowledge about chillers and industrial refrigeration plants, you can visit mundochiller.com and take our private programs for the training of professionals in the sector. Every month we are opening courses with new groups online modality, because it will not be the same amount of flow
of refrigerant that enters through the diffuser that is in charge of converting the speed into pressure. Remember that it was said in the previous class that the chiller's operating principle is to accelerate the refrigerant and after that speed convert the impression through a diffuser. If we see the animation we are getting closer, we are in the impellers and we see that we are going to go out and mount this diffuser that we have at the exit. That geometry of the diffuser has to change to also adapt to the amount of refrigerant that is entering. If less is entering we cannot have the same refrigerant. It is the same area that if a greater quantity is entering, then we are going to have a throttling or a variation in the geometry of the diffuser at the outlet of the compressor, at the outlet of the impellers. This area will then allow us to achieve the pressure that is needed. Logically we cannot have, as we said a minute ago, we cannot have the same refrigerant flow section when the amount of gas that is being fulfilled is less than when it is greater. There we see how the area is changing. In this way it is tied to the refrigerant charge. This diffuser is going to be in charge of partly transforming the velocity into pressure, and the velocity into pressure is transformed when the area of passage is being changed. So kinetic energy is converted into energy in the form of pressure. I think that with this animation it is very clear to at least begin to learn more about the operating principle of these machines. They are machines that provide us with a fairly high level of efficiency. The efficiency of these machines can reach, as we said last class, up to 0.3 kilowatts of electrical consumption for each refrigeration ton. Of course, it will depend on the configuration of the machine and also on the installation of the chilled water plant. We can do nothing with having a very efficient compressor, a very efficient chiller, but if the installation of the chilled water plant is not correct, well, we can lose that efficiency in the distribution of ice water. Here we can see the section where we can see when the refrigerant enters and how the two regulations change almost in parallel, in order to allow the refrigerant to only comply with what is being needed. This animation is very clear, and on this side, I think there are no doubts about what the control that is being done to regulate it would be like. Another way to regulate it is also varying the speed. Here we are just changing the passage area. By changing the speed we are also going to change the amount of refrigerant that is being supplied, but also since the compression is generated by speed, it is easy to understand that if the speed is lowering, the refrigerant pressure will also be affected. Unique effect is the amount of refrigerant. Then the RPM of the centrifugal compressor is being varied. These centrifugal compressors generate quite a large saving, especially when the bearings, which is the technology that is currently being used when the bearings are oil-free. When the bearings they are free of oil, so the performance increases even more because we are not going to have, firstly, we are not going to need a lubrication system in the compressor, we are not going to need it, and secondly, we are not going to need either, that is, there is going to be no presence, rather, of oil in the exchangers. That will also increase the efficiency of the machine. The fact of not having oil will reduce the chances of failure when we use bearings without oil, and we will also increase performance. We will create one more machine, reliable and higher performance machine. This technology is based on the use of magnetic type bearings, also known as magnetic lift bearings. This type of magnetic lift bearings, usually also known as RMA bearings, are based on the principle of electromagnetism by the which the compressor shaft rises, and once the compressor shaft is above it starts to rotate. The control of this type of bearing is quite strict because, as is known, the loads will always attract the shaft. It will always try to attract itself towards the bearing. The stator is going to be the part. The stator of the system is going to be the part that is, let's say, in the casing, and the compressor shaft is going to have a kind of magnetized ring to then achieve the electromagnetic phenomenon and make the compressor stays in the air. Also, with the use of magnetic lift damp compressors, it has been extended to smaller brands. This type of equipment stands out quite a lot, whose cooling thermal load. The highest performance will be observed when the load is below 70%. It is recommended when it is believed that the chiller will work in a considerable range of time. At a load of less than 70%, it is recommended to use this type of bearings. This type of system basically consists of two type bearings, radial and an axial type bearing, to be able to correctly carry out the elevation of the equipment. These chiller equipment can also further increase the efficiency when they use economizer containers with economizer to then be able to take advantage of the flash gas that is produced in the expansion. We can also see that these compressors use a synchronous type motor. This will also help to further increase the performance of this type of machine. The invitation is then to our next class, number 10.